Yeah, I starting
Yeah,
with math too.
exactly, exactly. I hope they can come to class early.
Yeah,
The early morning class is a problem for them.
it's not easy.
You yourself, I'm sure you didn't sleep.
Oh, I slept.
Okay,
I slept early.
okay, that's fine. Because normally early morning class, the slightest sleep that you go beyond your normal sleep.
You wake up around 9.
Exactly, exactly. I'm just hoping that the network will not be a challenge.
Because of the rain.
Yes, these days is been serious in so many places. I don't know why.
Yeah.
But I hope the subscription for the Zoom link has been paid or they haven't paid it. You are not aware.
No, that one unless.
Oh, okay. Because normally they have to do it so that it wouldn't be like it's been happening sometimes midway, then those,
Okay.
uh, because that also creates a problem. But I'll find out. I'll find out from your new head.
Oh, okay, okay.
Okay.
And please, this slides too. I don't think it's on elements. Or when we are done, you share with them.
No, it's there, but I've put it in a different way. This I'll use this for presentation. This is
Okay. And
uh,
we should use the textbook.
yes, but even the LMS, I don't know the last time you check. I have
Uh,
posted this one too. I made it presentation slide also together with the textbook. When was the last time you checked the LMS?
I'm here. I'm there now.
Okay, so let me see whether I can also get it because I remember I
I've seen
posted.
the textbook. The textbook for business
But
statistics.
before the textbook, haven't you seen any course outline? Uh,
Okay. Course
yeah,
present.
yeah. So open that one. That is it. That is it.
Okay. Yeah, I opened it yesterday. Okay, okay, okay.
I did it in the form of PDF for them, but
Yeah.
I'm using the PPX. Yeah. So I'm still populating it. I'll do it with the other
Okay, okay.
assignment with them, and then the mid-sem. Those are the things I'll add to it.
Yeah, okay, okay. I've seen it.
You seen it? Good.
Yeah, yeah.
Mm. I think I did it 4 days ago or 3 days ago, one of them. Joseph, where are your people? Are they sleeping?
Hmm. I'm chatting them now.
Okay, good, good. All right, then let me leave you to chat them.
Okay.
Yeah. Good morning, sir.
Yeah, morning. How are you?
I'm doing well, sir. Say yourself.
Yes, by God's grace. And
We thank
where
God.
are your people? Are they
Yeah.
sleeping?
So they are coming. They are coming right now.
Mm, okay.
Yes, sir.
So, we are working with time. So at 7 o'clock,
Yes, sir.
yeah, we may have to start so that it wouldn't disrupt the institute schedule.
All right, sir. So they will join very soon.
Okay,
Thank you.
right. All right, so good morning, class, and I'm happy to meet you once again this start of the second semester. We were able to do business mathematics during the first semester, and then we want to continue the semester with business mathematics. So ordinarily, somebody may ask a question that what is the difference between business mathematics and then business statistics? It's very important we know the distinction between the two so you can appreciate why you are doing business statistics this semester. Okay. Now, the business mathematics we did, it really gave us the mathematical tools to generate data. So business mathematics is a tool that helps us to generate data. So for instance, if you remember, we were doing a lot of topics, and one of them was the board mass and then the bed mass, just to recall that topic. So we get a long expression for board mass where we need to apply the operational signs of positive, negative, multiplication, division, and so on and so forth. And then we use the tool of business mathematics to order the operations, which ones to solve first. That is, having brackets, you solve the bracket first. And then after the brackets, we also learned how to use the off as the second operation. And then we also learned how to use the division as a second operation. We came to the multiplication, we did the addition, and then the subtraction at the same time. So when we worked something like this, sometimes the final answer we may get is, let's say, 5. Okay. The 5 we get as our final answer, that is the data we have generated. So that is business mathematics. We did computations to generate data. Then the question is, what is data? Now, data by definition, we call them raw facts. Data are raw facts. So raw facts means that it is an incomplete information. You can't do anything with them. Okay. So this board mass example I'm giving, assuming the answer was 5, this 5 you are seeing here is what I'm calling the data. And the definition of this data is what I'm calling the raw facts, because 5 doesn't mean anything to me. It's 5 what? But what business statistics, which we want to start today, what business statistics is going to do is that all the raw facts or data that we generated with business mathematics, the business statistics is going to change. Is going to change all the raw facts into information. And that is what we need in business. In business, we don't only need raw facts. We need business information. So our responsibility or our main objective is that we are going to use business statistics to change our raw facts, which is data, and make them information with the business statistics. That is the background information I want to give you. That our main objective is to change data, which are raw facts, into information. In other words, it's not enough to do business mathematics. You have to finish business mathematics with business statistics. And so in business, we move in a form of a triangle. You have data, you change the data into information. The information helps you to take a quality decision. If your quality decision doesn't work, you go back to the data to go and start again. You change it to quality information. And then the quality information helps you to take a quality decision. And so if I have any explanation for you as to the reason why we are doing business statistics this semester, this is the basic information we can get for now. That we are now interested in changing data into information. Once I've met this class before, I have uploaded the course outline and the course notes on the LMS. So I wouldn't like to go through all this. When you download these documents from the LMS, you still see what we are working with as a class. So as usual, you have some assessment being done with assignments or probably adding mid-semester again, and then with your final examination. And I'm sure when your results are released, you see some of these grading systems I explained to you during the first semester. So all these, you can read them, and then probably we can start from this page where the courses for the semester have been outlined here. So, we have to cover 4 units in our course notes. We will start with statistical measures 1, and continue with statistical measures 2. Then we turn our attention to probability theory 1, and then we do probability theory 2. The subtopics under these areas are the ones I have typed in move. Introduction to statistics, measures of central location, measures of dispersion, measures of position, measures of shape, basic probability theory, discrete probabilities, and then continuous probabilities. Now, the calculator I recommended during the first semester, we are still going to use it. In fact, this time we'll use it even more intensely than the first semester. So those of you who were not able to get the recommended calculator, please, I'm bringing it to your notice again. Go and look for this calculator, FX 991 ES Plus Scientific Calculator. That is what we'll be using to do most of our computation. And so this will end the course schedule for the semester. We need to go through these 4 areas. Now, the roadmap for this course. I I've given you the initial information that the focus of this course is to convert data into information. So I'll go to the board mass example I gave to explain to you why we need to convert raw data into information. Now, this is what I did here. I said, oh, I have a board mass problem. I solve it. I get 5 as my answer. What does the 5 mean? Because the 5 is an incomplete information. The 5 you are seeing is an incomplete information. And this is my reason why I'm saying the 5 is an incomplete information. Now, this same 5, watch it. This same 5, if I repeat it 3 times like this, and then the first one I put YEARS here. The second one I put the Ghana currency symbol at the back. And then the third one, which is this 5, I put tables, the word tables here. Now watch this. I have transformed the 5 because when we work the question, these numbers you are seeing here, nobody assigned any symbol to them. Nobody assigned any symbol to them. We just worked it out and we had 5. And I said the 5 is incomplete information or it is a raw fact. And raw facts are called data. But see what I've done to the 5. When I put years in front, it becomes 5 years. Is it giving you information? Yes, it's giving you information. Because what does 5 years mean? 5 years is talking about age. So it means that we have information about age. This same 5. Then when I put the CD symbol behind the 5, it has now changed into money. So this 5, this time is not giving us information about age, but is rather giving us information about money because the symbol we are seeing is giving us a hint that this is money. And then finally, this same 5, when I put tables in front, it makes it items because tables are classified under items. So then it means that we have information about items. So that is what business statistics is going to do. Unlike business maths, where you only have data as your answer, business statistics is going to give you information. It's going to give you information about data. Now, to use one sentence, now to put all of them together, which will be the foundation of our studies. This is what I can write as a statement for you so you can remember the reason why we are doing business statistics. Now, in the statistical world, we say that information, as you know the spelling to be, information hides or information, let me put it in the proper grammar. You say information is hidden. Information is hidden in data. Information is hidden in data. So it means that you can have information, but it's not available because the information is hiding in data. And until you crack open data. So it means that our responsibility for this course is that we need to crack data. So we need to crack data, or we need to open up data. So once we open up data, then the information that is hiding can be retrieved. The example we did, I said we had an answer as 5. This is data. Now, what is hiding in this data? In other words, what can you add to this to change it from data into information? And those were the examples I did. I added years. It became 5 years. And then that was the information. I added the CD symbol. That was the information that was hiding in data. Then I added tables. That was the information hiding. Why do we need this at all in business? And that forms the foundation we want to start with. That is our roadmap. The reason why data cannot be left unused is because when we crack data, if this is data, when we crack data, what we can get from data is information. And then we don't stop there. We don't stop at information. What do we do with information? We use information to take quality decision. If our quality decision doesn't go well, it means we need to come back to the data we started with, modify the data, and then go around again like a triangle. So because we are business specific, we see in this world, you always come across. What do you do with the business data? You change the business data into business information. What do you do with the business information? You use it to take quality business decisions. And that is our main roadmap for this course. We'll be dealing with a lot of business data. And what will be our purpose? Our purpose is to uncover the business information that is hiding in the data. And then once we get the information, we have to make good use of the information. Last practical example, and then I'll descend to now use the technical terminologies I have written there. Now let's look at a common commodity you and I know called rice. Look at rice. Okay. Let's say you have 5 kg rice, small bag. You bought this from the market. Now, rice, per its nature and appearance, looks like data. So we can call uncooked rice data. Why? Because they are raw facts. you can't consume uncooked rice straight away from the bag without cooking it. So in that sense, they are raw facts, is data. What do we do? What do we do with it? Is there any information hiding in rice as data? Is there any information? Yes, there is. Because this same rice can be changed to several delicacies. You can use it to cook jollof rice. You can use it to cook fried rice. This same rice, it doesn't change. You can use it to cook what we call the plain rice. You can use it for rice balls. I mean, name all the rice food. Now, all these are information that we're hiding, that we didn't know until we cook the rice. We didn't know this information, that you can have all these delicacies hiding in the raw rice we have bought from the market. And that is how business information is uncovered. How do you get jollof rice from rice? How do you get fried rice from rice? How do you get plain rice from rice? How do you get rice balls from rice? It means that you need to go through a cooking process. The cooking process is the process that is used to uncover the information you have in rice. So you and I know that the cooking process for jollof is not the same as the cooking process for fried rice. Again, the cooking process for fried rice is not the same as the cooking process for plain rice. And then finally, the cooking process for rice balls is not the same as the cooking process for plain rice. In other words, there are several ways that can be used that you can uncover business information from business data. There are several ways, just like there are several ways that rice can be converted into jollof, fried rice, plain rice, rice balls, and so on and so forth. In the same way, we can get different business information from business data. Now, one of the processes or some of the processes we are going to use to get business information from business data in the course of our studies are the ones that I have listed in the yellow areas. So the first process we may use is central location. This is also a second process. This is a third process. This is a fourth process. This will be the fifth. This will be the sixth. This will be the seventh. This will be the eighth. 8 different processes on the same data, but we are going to get different information at the end of the day because we need different kinds of information for our business. And so, in conclusion, for this roadmap, we want to understand that anytime we see a business data, we will consider it as raw facts. It means we have no information yet. The information is hiding inside the data that we need to open up the data to uncover the information. Once we work on the data, we say we have processed the data. So another word for information is processed data. It means that anytime you process data, you will have information. Then when we have information, we don't stay there. we need to proceed to decision. So we call it we call decision processed information, because anytime you process information, you get decision. Now, what is the link? What is the link between information and decision? Very simple. We started by saying that the rice can help us get several delicacies. So the raw rice, the information we had was, I wrote jollof as the first one. Then I wrote fried rice as the second one. Then I wrote plain rice as the third one. And then I wrote rice balls as the fourth one. Now, these are the information we are getting from rice, which is the raw data. Now, how do we then move to decision? That is what happens. So you go to a party. You go to a party, and then these are the 4 delicacies that are on the table. And then the serving is in such a way that they are in packs. They are all in packs. They have been packaged. And so you are being called to choose one. You are being called to choose one. That is where the decision comes in. Probably you are the type, you like jollof, you like fried rice, you like plain rice, you like rice balls. But at this point, they are asking you to choose one. You can't choose it easily like that. You have to go through your mind and arrange these ones in order of preference. That which one do I like best? Followed by what? Followed by what? Followed by what? And that is where the decision comes in. That you can't only stop at information. You have to proceed to decision. And then once your decision is a quality decision, in business, all we want is we want money, and then we want continuous productivity. So any good decision that you take is going to enhance your productivity as a business person, and then increase your revenue or the money accrued from sales or whatever business venture you find yourself in. So this is the explanation I can give to you concerning our roadmap, because we are taking off today. This is the roadmap we are going to follow. We'll come across business data. What do we do with the business data? We have to process the business data into business information. We don't stay at the business information. We go ahead and then we process the business information into decision. In a nutshell, the word data is going to be a common feature in all our workings, that we are always going to work with business data or raw facts. And then finally, we go and end our calculations with our business decisions. And this is the introduction to our course today. So with that behind us, let's now start the theories and the concepts in the business statistics. Now, there are these 2 words that I'm sure you've come across before in your life: probability and then statistics. We want to get some basic understanding, and then we can process them. Now look at this illustration here that says that you always have a sample. You always have a sample. and then you always have a population. So those of you who don't understand a sample and a population, let me still help you with the rice example. Now, if you buy a 5 kg rice in a bag, 5 kg rice in a bag, and then I ask bag on the ground because I want you to carry out an exercise for me. I want you to, like I'm doing for your illustration, I want you to count all the rice particles of the 5 kg in the 5 kg bag. I want you to count all the rice particles, probably for an award or something. I'm sure you will not even try. You will not start. Why? Because the particles are too many to count. They are too many to count. And I'm sure you will make a lot of mistakes because there are too many to count. That is what we call a population. A population is some number of either items or humans where you are finding it difficult to count because there are too many to count physically. And so in this world, we don't waste our resources and time counting population every time. All we do is we take a sample, we study the sample, and then we use the sample to make a generalization about the population. So with the same rice example, assuming I said, open the rice bag and then pick your spoon, maybe your tablespoon like this, and then scoop a spoonful of the rice, then pour it on the table, and then count them for me. This one looks very easy. This one looks very easy, unlike the first one in the back. So this one, you can handle it because it is easy. In statistical language, anytime you have data that is very easy to count, that is very easy to count or to be counted, we call it a sample. And then anytime you have data, like the 5 kg rice, which is very difficult to count, we call it population. That's the difference between sample and population. For sample, it is very easy to count the items, but for population, it is very difficult to count the items. In this case, how do we then get information about population? Because if you are not able to count population, you can't get what we are looking for in this course, information. All we are looking for in this course is business information. So if you can't count a population, how do you get information? That is why this illustration is there. Anytime you want to get information about a population, in business statistics, we say go and look for a sample. After getting the sample, use the tool of statistics. to work on the sample. Once you use the tool of statistics to work on the sample, the results you get is the population you are seeing here. And this is natural. Example, the same rice in the 5 kg bag. If you use a spoon to scoop 1 spoon like this, and then the rice particles you saw were looking very nice, and probably whitish. I'm sure your mind will conclude that the whole bag of rice will also look nice and whitish, even though you haven't opened the bag and then probably push your hand to the last end of the bag to check the appearance of the others. But because the spoon sample is giving you some appearance that are looking nice to your eyes, your conclusion is that, oh, this rice will look nice. Second example, when you buy food and the food is served in a plate for you, or you have a soup in a bowl, and then for the first time you use your spoon to scoop just 1 tablespoon. Now, when you taste the volume in the spoon and it appears that it is very delicious, you don't need anybody to tell you that. Then the whole soup in the bowl will also taste delicious, because your mind tells you that just as the taste in the spoon is okay for you, it means that the rest that is in the bowl will follow the same thing. And that is what statistics does. Statistics gives you the opportunity to know what is happening in the sample. Once you know what is happening in the sample, then you can conclude that the whole population is like that. And that is one of the techniques we'll be using to always change the characteristics of sample into population. So that is the first direction of my arrow that you are seeing here, that you can always use a sample to make a generalization about a population. And then there's the reverse. There's also a reverse. And the reverse is that you can also know about a population, and then the population can also give you information about a sample. And that is how the direction works. Use a sample to get a population by using the tool of statistics, or use population to get a sample by using the tool of probability. So when you see probability and statistics, they are moving in the opposite direction. Whilst statistics is moving from left to right, population is moving from right to left. And I'm sure as we go along the semester, you will know the differences between the two and how we need both, not one. In business, we need both to be able to survive in the business environment. Now, the basic definitions we can have for these concepts are the ones I have listed below. So when you hear about statistics, it means you are trying to work your way around, starting from a sample and then ending with a population. What does it mean? It means you don't have the full picture when you are having the sample. You don't have the full picture. So what do? It means that you have to use the small you have, okay, to make a guess about the whole group. And that's what we've been doing all morning. Use the small you have to make a guess about the whole group. So if the spoon of rice is the small, and then the bag of rice is the big. If I open this one slightly, how do I know that the ones under here, which I cannot see? Because when I open the rice, I only see the surface. I can't see what is below here. But statistics is telling me that no problem. Just look at the small and then use it to know about the big or the whole group. So like the example I gave, if the appearance of the particles are nice when you use the spoon to scoop just one, it means that the ones that we haven't seen below the bag will also look same. That is how statistics work. And then probability, like we illustrated, also goes in the opposite direction. You know about a population, and then we can then now take a sample from the population. We know about the population, we take a sample from the population. So let me use your class rep. Now your class rep or your course rep, Joseph, is the sample. Okay, so let's say Joe is here. Joe is the sample. Then the whole class of probably about 32, you are forming the population of the class. And then Joe is a sample from the class. So now Joe can now move to the class, into the population. So now when we see Joe, then we see that these are the level 100 procurement people. Then what about the reverse? The reverse is population to sample. Then I can also say that when I go to the level 100 procurement, logistics, supply chain, transport class combined level 100, it means that when I go to that class too, I can see Joseph, who is the sample. That's the reverse. So to see Joseph, I can go to the class because I know the class he is, and then I pick him out as a sample. Or when I see Joseph, I know that he belongs to the level 100 class, so I can move to the level 100 class. That is how the population to sample also move. So the quick key takeaway that we can pick from this side is that always remember that you can move from sample to population in one direction or move from population to sample in another direction. The reason is that the characteristics of a sample can be used to generalize the characteristics of a sample can be used to generalize the characteristics of a population. If the rice is nice in the spoon, it will also be nice in the bag. Can we put the rice in the bag that is moving from sample to population? Yes. Can we also scoop rice from the bag to the spoon that is population to sample? Yes. And the two terminologies we give to such movements are one, statistics, and then two, probability. And like I said, we'll look at the details of this in a bigger picture. Still on this illustration, let me now bring in business examples as to how to move from sample to population using statistics. Now, example, we can use 50 stores sales. Let's say you have so many stores around in Ghana. Let's say you have about 1,000 stores in Ghana. Or let me not even use stores. Let me use the popular places you've been going to. Let's use KFC. Let's use KFC. So we say maybe 50 sales in a 50 KFC points sales can be used to get its national sales. So let's say KFC has about 200 joints in the whole country. The question is that, can we use the sales of 50 of them to know about the national sales? Yes, because their brand is the same anywhere you go. The way they do their chicken doesn't change. It's the same. And people patronize their products. So when you are taking just a few of the joints, we say you are picking a sample of KFC joints. Can you use it to generalize all the KFC joints we have in Ghana? Yes, you can do that. That is sample to population. Or the reverse. Is it possible to look at these 200 joints and pick about 50 of them whereby they can still make good sales? Yes, you can still do that. So this movement from sample to population still has two directions. The first direction is statistics, and then the second direction is probability. So in another form, we can go by it this way, that you will always find a sample within a population. And then once you find a sample from the population, it will keep going round in terms of characteristics, and then finally come back into the population. Or a sample can be taken from the population, and then it will go in another direction. In that case, we call it the inference process. The inference process. It means that this thing is predictive. You can take a decision on it. Sample will never deviate from population when the characteristics are clear. You cannot take rice from a bag of rice and say that what you took from the bag is different from what you are seeing taken out. It's not possible. Because if this is the bag and these are the particles, anything you take from the bag is a sample. And you can take several samples from the bag. But the key question is that, are we able to analyze all the particles in the bag? No, we cannot do that. Are we able to analyze all the sample of rice we took with our tablespoon? Yes. And those of you who have experience, you see that some of the particles at close range, some of the particles of rice look smaller. Some also look bigger. Others are of medium sizes. They don't look too big. They don't look too small. And so if I ask you to separate for me smaller particles, bigger particles, medium particles from the one you took with your spoon, it becomes easier. That one looks very easy. That can be done. But if I say do it for the whole bag, that would be very difficult. This is the reason why we always have to learn how to relate a sample to a population. And that is the extensive information I wanted to give you about why we can always use a sample to infer, use a sample to infer a population or to talk about a population. And these are real life examples of why we use a sample. Businesses, governments, and scientists use this idea all the time. Example, some of the posters we have can use some few voters to predict election results, which has been working every time. Because you can't go around asking everybody who they will vote for, but you can go around asking a few voters who they want to vote for. And the information they give you sometimes shows that majority of the people are thinking like that, even though you haven't asked everybody the question. In real business activity, you can ask few customers about what they understand about their overall business satisfaction. You can't go around asking everybody, but the feedback you get, if the feedback is positive, then you assume, that's what we do in business, then you assume that people like your product. But if the feedback is negative, it means that you have to work on your product, because your mind will also tell you that just as few customers are saying it is not good, it means majority may also say the same. And that is another example that we can look at. Now, to put all this together, how do we then get information from data? Because that is what we need at the end of the day. We need information from data. How do we get information from data? All we do is, first of all, get a sample from where? We get a sample from a population. And the only way we can get a sample from a population is that we need to go through statistics. In order to have the sample from population. And we are now specific. We want to use business statistics. to move from sample into population. To move from sample to population. There are a couple of processes that we'll go through, which I want to illustrate with the next slide, which is this one. In our business operation, this is what we will go through, or this is what is normally done. The business operation is all about two things. First of all, we need quality production or quality productivity, and the long run effects of the production is going to give us higher returns or higher revenue. So it's all about how much have you produced, how much revenue are you getting. And we can only do this if we are able to look at our business data and then we see how we can transform. Look at the blue arrow, how we can transform our business data into business information through business statistics. So this is where we are now. We are using business statistics to convert our business data into business information. And this can enhance our business operation or business operations. How do we link these three? What is the relationship about these three? Business data, business statistics, business information. This is the relationship. Now, if you have these two tables here, the X is representing input, and then the Y is representing output. The X, which is representing the input, is your production cost. You know that before you do any product, like we were taught in the lower levels, you always use cost prices to produce. Okay, you always use cost prices to produce. And then after that, you sell. And then that is where you get your selling prices. Once you have your cost price, once you have your selling price, there are three scenarios that can happen. If your selling price becomes greater than your cost price, it means you have made a profit in the business. The second scenario is also that when your selling price is less than your cost price, it means you have run a loss. So while this is profit, this one you've made a loss. And then the third scenario, when your selling price is equal to your cost price, it means that you are breaking even. Now for this illustration, we have our inputs. That means the money that we are pushing into the production. So you have $1 million First month, $2 million. Second month, $3 million. Third month, $4 million. Fourth month, $5 million. Fifth month, and then $6 million. Sixth month. Now let's look at the revenue, the money the company had. In other words, we'll say this side is our cost price or cost prices, and this side is our selling prices. Okay. Now, if you have a cost price of $1 million, and then after selling, you get $3 million, it means you've made profit. That is positive. If you use $2 million as your cost price, and then you have $5 million plus dollars, that is also positive. So the first one is positive, the second one is positive, the third one, 3 million against 7 million plus, that is also positive. The fourth one, 4 million input, 9.3 positive. Fifth one, positive. Sixth one, positive. Now, if I show you a data like this, well, you are seeing that the thing is increasing, and we are all happy about it. But if I ask you a question, how did this 3 change to 5? How did this 5 change to 7? How did this 7 change to 9? How did this 9 change to 11? How did this 11 change to 13? You can't get any useful answer for me, because this is just data. Okay, this is data. So we've also established that data is always raw. They are raw facts. Data are raw facts. These are raw facts. So we don't have information yet. We don't, because if I ask you to explain why 3 has changed into 5, you can't tell me plus 2. If you add 3, if you add 2 to this one, you get 5. If you add 2 to this one, the answer you get, that's not what you are getting here. If you add 2 to this one, the answer you are getting, that's not what you're having here. If you also add 2 to this one, there's a different answer here. If you add 2 to this, there's a, so you can't make meaning out of this. Okay, because they are raw. So when somebody then come and ask you in future, they're looking at your data. If you invest 7 million, how much are you going to get here? You can't say anything. You cannot say anything because why? You have not processed the data. Until you process the data, you cannot say anything. We have to process this data before we can talk about when you invest 7 million, what are you going to get? And so at this stage, we are here. We are seeing this one as our business data. There is no information. There is no information. And right from the start, I told you that we business people, we are interested in business information, not business data. The question is, how can we turn this into business information? Well, once we are able to turn it into business information, it means we can understand the money we can get when we make 7 million inputs into the business. We can now tell the returns we are going to get at the side. Until that, we cannot predict anything here. So we need to process this one in order to have our business information. Okay. How do we then process or do the processing? We are going to use this course, Business Statistics, to process the business data in order to arrive at our business information. So one of the business statistics we'll be using to process data like this, we call it correlation and regression. We haven't gotten there. I'm just trying to mention it so that when we start, you can recollect that we have seen it before. We'll use a business statistics concept called correlation and regression to change this data into business information. And that is what I did here. So this is what is going to happen. We'll use that concept to plot these points because we are looking for a relationship. There must be a relationship between X and Y. There must be a relationship between input and output. Once we see that relationship, we can be able to predict the money we are going to get when we invest $7 million. So the process is we plot one against the other. And those are the blue plots you are seeing. Those are the blue plots you are seeing plotted. So for instance, if I'm to walk you through this one, the first point, which is 1, which you are seeing here, was plotted here. This is the first one. So this is the first one, 1 against 3.048. And then it's not arranged properly, but the 6 points you are seeing here is what has been scattered here and is being plotted this way. So what the business statistics is going to do is to find the relationship for these 6 points. What line can relate all these 6 points? You see that at the end of the day, we'll end up plotting a line that is moving in such a way that the distances of those that are above the line and those that are below the line, if you put them together, they will lie on the line, or they will come closer to the line. So this distance, this distance, this distance, if you put the distances here also together, this distance, and that distance, they will all lie on this line. So in other words, this line becomes their line of relationship, that assuming you are pushing all of them to be on this line is going to accommodate all of them for us to be able to predict the inputs of 7 at the end of the day. That's what we are looking for, or any other input. Now, this relationship line that you are seeing here after plotting will give us our business model, which will give us the business information. And when I plotted that, I had this relationship you are seeing here. Y equals 0.934 plus 2 0.114x. Now, the meaning of this relationship is no problem at all with the ones you have here. It means that as you go down, all you do is that just fix the x value here, multiply by 2.114, add 0.934, and that will show you the expected output or money that can be received when your production or input is $7 million. So as an example, let's try this one. Assuming we want to know about 7, the value we'll get here. How do we know the value we'll have here? Now, this is the relationship our business statistics has given us. Our business statistics says that we should use this relationship formula, and that will give us the results we are looking for. So all you do is you pick your calculator and then we fix 7 in. So to get the value here, let me create a space for that. To get the value here, you pick your equation y equals 0.934 plus 2.114. Now x inputs, our input is now 7, this 7 here. So multiplied by 7. Let's do this on our calculator and see the results we'll get. We'll keep our answer in 3 decimal places like you are seeing the others. So 2.114 multiplied by 7 plus 0.934. When you do it on your calculator, you will have 15.732. And this makes a lot of sense now. This is the information we are looking for. That how are these numbers changing from one to the other? How are these numbers changing from one to the other? It's because we've been able to use business statistics to convert business data into business information. Okay, so once my statistics is working, I don't need anybody to show me what I'm going to get in future because I have my business statistics here. And so when another person comes and says that, okay, now help us with the prediction. We now want to invest more than $6 million into the business. Show us how much we are going to get. And probably you ask them, how much are you willing to input? They say, we want to bring in about $120 million as input. Show us the expected money we can get if we invest $120 million. You just pick your business statistics model. So you have y again equals 0.934 plus 2.114 multiplied by this time $120 million. So we do the calculation again, this time using the $120 million by multiplying 2.114 by 120 and then adding 0.934 to it. And the final answer we'll have is 254.614. So you have 254.614. So life becomes easier here. That once you've been able to convert your business data, which was raw. Initially, it didn't make sense to us. Before we saw this plotting, it didn't make sense to us. You invest 1, you get 3. You invest 2, you get 5. You invest 3, you get 7. You get. Then somebody says, I want to invest 120. What will I get? If you don't process this data, how do you know that when you invest $120, you can get $254.614? And that is one of the reasons why we need to understand this concept of business statistics. And so with all these examples I've given, I want to then define statistics for you. And then probably after that, I'll open the floor for your questions. We've been doing a lot of examples, and you've been hearing me use the word statistics, statistics, statistics. Let's now go deeper into it now. When you are asked, what is statistics? What should come into your mind? Now, statistics can be explained in a simple manner. It means you are making sense of data. That is all. Statistics is the area or the field or the paradigm where you make sense of data. These 3 keywords: making sense of data. Making sense of data. The reason why you need to make sense of data is that, like I've been consistent, I always keep saying that data are raw facts. Until you make sense out of raw facts, you can never have any information. So statistics is all about making sense of data. That is all. Now, once you are prepared to make sense out of data, it means you have to use some methods to make the sense out of the data. And the 2 methods we'll use generally, we call them the statistical methods. The 2 of them we want to use, if you go through your course notes and your slides, are as follows. The first one is called descriptive statistics, which you know some aspect already from the lower levels of your education. And then the second one is called the inferential statistics. We are going to always look at these 2 tools to make sense of data. Data are raw facts. We need to make sense out of it. And so, in summarizing what we have done today, and then to open the floor for your questions, I want to emphasize that data can always be changed into information. Data can always be changed to become information. Information is not static. Information will also have to be processed into decision. So the arrangement of business data as we've extensively discussed today, to business information. And then to business decision are all processes that are linked like a chain. You move from one point to the other. We will always have business data. We will always have to process this business data to get business information. We will always have to process this business information to get business decision. And I'm saying that making sense out of data so we can be able to achieve this process, we always need these two statistical methods to do that. The first one is called the descriptive statistics, and then the second one is called the inferential statistics. The descriptive statistics, all it does is just to describe the data for you. So this will always describe the data we are dealing with for us. And then what the inferential statistics will do is that it will always give us a conclusion about the data. Whilst the first one will be describing data for us, the second one will always give us a conclusion about the data. So the two will work together. We'll have to start somewhere and then we'll end somewhere. So in other words, we are going to begin, or we'll always begin with the descriptive statistics, and then we can end with the inferential statistics. Now, when you are doing the descriptive statistics, there are some metrics that help you to describe the data. So for instance, God willing, next week, we'll start looking at how we can use tables to describe data, how we can use graphs to describe data, how we can use numbers to describe data. All these tools are under descriptive statistics. And sometimes you have to see data in a form of a table. You also have to see it graphically, like a graph, or pictorially, like a picture. And then you may understand what it's used for. Sometimes too, you have to understand it in the form of numbers. For instance, if I write this thing, 100 years. If I write 100 years, you don't need me to draw a graph or to do a table for you to understand 100 years. 100 years has been described already in your mind because you know how 100 years old people look like. So sometimes we use only numbers. That's what we call the numerical measures. We only use numbers to describe data. And all these are under the descriptive statistics. Then finally, the inferential statistics, like I said, it will always conclude the data for us. It gives us a conclusion about the data and then how we should see it. And I will end with the rice example to explain the two at the same time. So back to the rice example. In the beginning, I said that you have 5 kg rice in the bag this way. We don't know anything about the rice until you open the rice from the top. Now, when you open the rice from the top, and then you take your spoon, not even a ladle, you take your tablespoon and then you scoop some few pieces. Okay, let's say the few pieces you scooped with your spoon, when we counted them, we were able to record, let's say, 300 pieces. We were able to record 300 pieces with the few that you scooped with your spoon. Now, the 300 pieces we saw, like I said, the appearance of the rice particles were very nice to look at. So let's say they were very nice. Okay. What we have done here is called descriptive statistics. We have described the rice. We have described the data. We have described the rice. We said, oh, after counting 300 pieces, we saw that the rice is nice. Now, out of the descriptive statistics, what conclusion can we do? What inferential statistics can we do to the whole rice? Then this is what inferential statistics will do. We can now conclude that once the 300 pieces are looking nice, then it means that all the rice particles in the bag will also look the same. They will also look nice. When you say that you have done inferential means that you are concluding or you are inferring or you are assuming. You are assuming that once the first few pieces are very nice, it means that all the rice in the bag are also nice. And so you always need descriptive statistics to help you get inferential statistics. You always have to describe the data first before you can make conclusions about the data. And this is how I want to relate the two for you, that you always get inferential statistics from descriptive statistics. And in conclusion, for the lecture today, all we are seeking to do from next week, all we are seeking to do is that we want to use statistics. We want to use statistics to make correct statements or to make inferences about a population based on sample. I take it again. All we are seeking to do is to use statistics to make correct statements about a population based on a sample. So, like a tailor or a seamstress, to tailor this for you, I will rewrite this as my concluding statement, that all we are seeking to do is to use business statistics to make correct or accurate, correct business statements. business inferences or assumptions about business operations based on business information from business data. So I have indicated my goal to you now that from next week, all we want to do is to use business statistics to make correct business statements or business inferences about business operations based on business information from business data. So I have come back to the roadmap we started with. In conclusion, I've come back to the business roadmap we started with. And this is where I started today, that our intention is to convert business data into business information, and then business information to business decision. And this will only be in the environment of business operation. And so everything will be business. And at the end of the day, we want to conclude by saying that all this will help us to maximize revenue or profit, which is the aim of every business person. And this is my last statement. The floor is now open for your questions. Any questions so far from the discussion we have had this morning? If you have a question, if you have a contribution, you can raise up your hand and then we can address it appropriately. All right, so yes, Gabi, I see your hand up. Unmute yourself.
Yes, sir. Thank you very much. I see this is closely related to data analysis. I don't know, I've not done much, but from what you've explained so far, I think it's more related. And also, I wanted to ask the intercept and the slope. Going forward, are you going to teach us how to do it, or it will always be in some of the questions?
All right, good question. Yes, I agree perfectly with your first statement. This is closely related to data analysis. And we are doing our analysis not in a scientific way, we are doing it in the business way. So we can qualify what you said as business data analysis instead of data analysis. You say we are going to engage in business data analysis, or some people call it business data analytics. We are going to analyze data. And why are we doing this? It comes back to my fundamental reason that all we are seeking to get is that we need information to work. We need information to work. And until we do the analysis, we cannot get the information we need to work. So yes, it's true. It's related to data analysis. Then secondly, the relationship graph you are seeing here, we are going to do it. We are going to do it. It's not like we will not do it. We will do it, and I was just using it here to show you how you can just look at data, change it into something, and then you can make meaning out of it. So yes, we will do this one under the topic called correlation and regression, which I'm sure when we get there, personally, you can use it to analyze some of your businesses, especially those of you who are in business already. You can use it to do a lot of analysis in business. So yes, we will do that. Thank you for your question. I see another hand up. Yes, Kingsley, unmute yourself and ask your question.
Yeah, thank you, sir. Sir, good morning.
Good morning.
Sir, it's still on the graph.
Okay.
The values of Y. Is it a case that values will always be given, or you have to work out for the formula?
So, yeah, right. Good question. So this is the idea. The idea is, let's take it this way. Let me handle your question in this direction. Now, assuming you yourself, you have started a business. You have started a business. Now, the first month, you invested $1 million. And then at the end of the day, you had a revenue or a selling price. So this is your cost price. You invested $1 million. You had $3 million. First month. Second month, you invested $2 million. You had $5 million. Third month, you invested $3 million. You had 7.2 plus. Fourth month, you invested $4 million. You had 9.3. So you see that you are being encouraged. You saw that anytime you increase the X, the Y goes up. And then you did $5 million, and then you had 11.5. It went up again. You did $6 million. It went up 13. So I'm saying that if somebody wants to help you and is saying that, okay, Kingsley, you know what? Your money are too small. I have about $250 million sitting in the bank. I want to bring it into your business. So with this record that you have, how much do you think we are going to get if I give you this $250 million to invest? How much are we going to get? Kingsley, I'm telling you, you can't give the person any answer because you yourself, you don't even understand the differences that are coming because your mind is telling you, oh, is it plus 2? If you add 2 to this one, you won't get this. If you add 2 to this one, you won't get this. So your mind is telling you that the thing is increasing by 2 million, but as to how it's increasing, you don't know. So if the person says, I'm investing 250, how much are we going to get? You can't say anything. Why? Because the data you have here, we call them raw data. You have generated it. It's called raw data. Okay. But we can only understand this data when we change it to become information. Until we change it to become information, you can't give an answer to anybody who tells you, when I invest $250 million, how much am I going to get? Now, straight to your question, will you be giving these numbers? Yes. if I want you to do data analysis like this, I'll have to give you these numbers so that you can use these numbers to generate this equation. And once the equation is generated, any number at all anybody brings here, when you fix it in the equation, you will get the answer you are looking for. So yes, if it's not your personal business and then somebody wants you to do this analysis, they will have to give you the inputs and then an output. And then we can use what I'll teach you this semester, the business statistics, to be able to change it from business data into business information. That is how best I can respond to your question. Yes, Suleimana, unmute yourself and ask your question.
Yes, sir. Sir, please, in maths, if you want to find slope, they have a formula for finding a slope. That is y2 minus y1 divided by x2 minus x1. So
Okay.
I need to use the same formula for this one or this one. You need to draw the graph before you can pinpoint the slope and the intercept.
Yes, so yes, I get you. I understand. So I understand what you are talking about. You were taught some time ago about the straight line graph where you have y here, you have x here, and then you do some straight line graph, and then you find the slope. And you were taught that in finding the slope, use change in y over change in x to find the slope, and then the intercept and all that. And the equation was y equals mx plus c. Okay. So we will not use this one. We are doing business. This is just core maths, but we are doing business statistics. So there's a business statistics formula we can use that can help us to find these numbers you are seeing here. It will help us to find this number. It will help us to find this number. And so don't worry, when we get there, I will use the formula. In fact, one good thing about this course is that I'm going to give you a formula sheet in the exam. You are not going to memorize any formula. I'll give you a formula sheet during the exams, and every formula you will need will be in the formula sheet to be used. So don't worry, I'll give you, there's a formula that is used to find the equations you are seeing here, which we'll get there very soon. No problem at all. You'll have a formula sheet for that. Any other question? Yes, Jonathan, unmute yourself and ask your question.
Good morning, sir.
Yes, morning, Jonathan.
Now, looking at this thing, the differences with the y values, I got to realize it's always 2.114. So can you just like by virtue of the use of mapping, let's say you just make it like the equation for the data there could be y becomes y plus this is 2.114.
Yes, again, your question again. I'm following you.
Yes, sir. So what I'm trying to say is that the differences in the y values is 2.114, meaning that if we are supposed to even find the x, the 7, the x7, or let's say the $7 million of the x, then we are going to just add the 2.114 to the value of y at the level of 6.
Yes. So that is it. So because the values are small, that is why we were able to see that mapping of 2.114. But
yes, sir.
Yeah, in real business, you will have plenty data like 10,000, 100,000. So if we don't learn how to use the formula to get the y, we will always struggle. That is why we want to learn how to use the formula and not just to map them, because it will get to a point it may not work. at the end of the day. So for now, this one we can use the mapping, but for a data I will show you later, it will be very difficult to use the mapping to add up that way, because things will change in the long run. So don't worry, when we get to the real life situation or question, we can then look at the formula very well. And I don't want to rush and show you the formula. I feel like showing it to you, but I don't want to rush and show it to you now because we haven't gotten there. When we get there, we'll use it. And that's a good contribution and a question. Yes, any other question for the day? This is just introductory. I didn't want to do some plenty calculations today. Today is all about introducing the course and then where we want to get to. So those of you who didn't see me do a lot of maths, that is the reason why. My main objective was to let you see the roadmap, that where are we starting? Where are we ending? We are starting from business data. Then we walk through business information. Then we end up with business decision. Then the rippling effect or the long run effect is that we want to enhance our business operation. And the two key things that can help us to enhance our business operation is by getting quality business information and then quality business decisions. Once we do that, we are okay, because we cannot stay at data. Data, like I've stated here, they are raw facts. We cannot stay here. We want processed data and then processed information. That is what is going to help us to maximize revenue and then to reduce costs or minimize costs. So I think we have interacted enough for the day. On this note, I want to thank you for waking up early. It wasn't easy at all waking up for this early morning class. Early morning classes are very difficult, but the participation has been superb. I'm really surprised the number of participants I saw at 7 a.m. You've done well, and I hope you keep it up for us to work through this semester as well. On that note, I will leave you to rest for your next class, and then God willing, next week we'll continue from where we are leaving off. I think I ended at slide 28, where I captured the goal of our semester. One more time, to use business statistics to make correct business statements or business inferences about business operations based on two things: based on business information and business decision, which we will always take from business data, which are raw facts. And I'm sure with this, at least, it will summarize whatever we have discussed today. And then, God willing, next week, we'll continue with where we are leaving off